Our solar system is receiving visits from giants. We already know about the interstellar object, 3I Atlas, which baffled scientists. Now, another object has arrived, Comet SWAN. What most people skip is the crucial detail. SWAN came from our own backyard, and its path is nothing like Atlas's. That one fact changes everything. It shows that visitors like 3I Atlas are not random. They form a separate class, so strange that some researchers have started calling them not visitors, but sentinels. A coincidence? The current mystery doesn't begin with one guest, but with two. First came the giant, 3I Atlas, a 7-mile-wide behemoth spotted racing in from interstellar space. It was the third known interstellar visitor, and by far the largest. Its path was odd, its origin unknown, and it immediately became the target of intense scrutiny. While astronomers struggled to explain this cosmic monster, a second guest appeared. On the 11th of September 2025, a faint glow was catalogued as Comet C, divided by 2025 R2 SWAN. At first, the two seemed like they might be related. People love the idea of cosmic families' fragments traveling together after a breakup in deep space. That tidy story would have made Atlas easier to digest. But when researchers traced their motions backward, the tidy story collapsed. SWAN is one of ours. It came from the Oort cloud, the vast, ghostly sphere of trillions of icy bodies that surrounds the solar system. Its journey is a slow, multi-million-year fall from the edge of the sun's gravitational realm. SWAN is a messenger from our pre-solar past. Atlas, by contrast, is an outsider, an alien. Its trajectory proves it came from between the stars and is not bound to the Sunday. The two appeared in completely different parts of the sky. In plain terms, they were strangers. That one fact destroys any simple kinship theory and opens a far darker question. SWAN's predictably normal behavior is the key. It became our control case. This is what a natural, long-period comet born in our system looks like and how it behaves. Its orbit, tilted about 111 degrees, is exactly what you'd expect from an Oort cloud object. That boring normality gives us a stark contrast to the profound oddness of 3I Atlas. So the question isn't whether they're related. The question is why Atlas is so different. For anyone hoping Atlas was just another strange but natural interstellar rock, SWAN was the worst possible news. It drew a clear line in the cosmic sand. On one side, predictable wanderers from our system like SWAN. On the other, these interstellar visitors, and the more closely we study them, the less natural they look. SWAN unlocked the cage and exposed the true oddity of the beast called 3I Atlas. To see why Atlas is terrifying, you must understand how we move through the galaxy. The sun is not stationary. It barrels through space at hundreds of thousands of miles per hour. Neighboring stars ride the same vast, twisting current, the average flow we call the local standard of rest, or LSR. You'd expect random interstellar objects to cross that galactic current with random velocities like a boat slanting through a river. Instead, we see something else. The first interstellar visitor, Oumuamua, was almost perfectly at rest relative to that flow, a chance 1 in 1,000. The second, 2I divided by Borisov, showed the same impossible trait. Now Atlas, again, essentially parked. A 7-mile mountain motionless in a raging river. 3 interstellar guests in a row sharing this vanishingly rare property. The odds are astronomical, and patterns like that demand explanation. For a while, scientists wondered whether some unknown physical effect forces objects to sit relative to the LSR. SWAN kills that idea. As an Oort cloud native, SWAN travels with the sun. It is not parked relative to the LSR. SWAN's perfectly ordinary galactic motion proves the parked state is not a general cometary rule, but a unique marker of interstellar objects. That is the rub. Atlas isn't just an oddball. It's part of a repeating, statistically absurd pattern. That pattern spawned a controversial but elegant hypothesis from Avi Loeb. What if these objects are engineered? If an advanced civilization wanted probes, sensors, or navigational beacons scattered across the galaxy, where would it put them? In fixed, predictable locations that are stationary relative to local stars, relative to the LSR, so they can be found and used. In this view, Oumuamua, Borisov, and Atlas aren't random rocks. They're buoys. Their impossible motion would then be a feature, not a bug. The theory neatly explains strange observations like Oumuamua's unexplained acceleration and why multiple objects share the same improbable orbital class. If even one city-sized object like Atlas is artificial, the stakes are enormous. We're not talking about a pea-sized probe. Atlas is town-scale. The technology to build and move such a thing would outstrip ours by so many orders of magnitude that it would appear as magic. That implies we are not peers among equals, but infants in a universe run by adults. Are we ready for that existential shock? Would religions, governments, and markets survive the slow unraveling of that truth? If Atlas is an artifact, it won't arrive with a trumpet. The proof will be quiet. Math, trajectories, probabilities. A string of numbers on a screen could shatter centuries of assumptions. This isn't theater. It's a slow, whispering revelation unfolding in orbital data. We only recently gained the instruments to see these visitors. We have just opened our eyes. SWAN gave us the control. Atlas gave us the anomaly. Between them lies a question that could rewrite our place in the cosmos, and we have a narrow window to study it before a 7-mile enigma slips away.